Yeah, it's a time now.
Jyotis, shall we start? Hello?
Hello, sir. We are about to start the program.
Okay.
A small issue. We will start soon.
Yeah.
Okay, let us start. Welcome back, everyone, to the sixth session of our 5-day online faculty development program, organized by Government Polytechnic College, Muttom, sponsored by Sitter Kalamasheri, in association with India Cements Limited, Q-Grade Readymix India Private Limited, Dr. Fixit Institute, and Pidilite. My name is Basil S. Jacob. I am the lecturer at GPC, Muttom. Now, we are moving on to our next session. Our next session will be handled by Mr. E. Gopalakrishnan, Head of Lab and Consultancy Services, Pidilite Industries Limited, regarding the topic non-destructive methods and advantage of assessing structural conditions. Let us have a view to his profile. Mr. E. Gopalakrishnan is presently the head of Advanced Diagnostic Laboratory and Consultancy Services of Dr. Fixit Institute of Structural Protection and Rehabilitation, which is promoted by Pidilite Industries Limited. He has more than 29 years of experience in his field and also proven his efficiency in the execution of infrastructure like highways, hydroelectric projects, Delhi Metro project, etc. He has also established Advanced Diagnostic Laboratory of Dr. Fixit Institute of Structural Protection and Rehabilitation in Mumbai. He played lead role in the completion of structural audits of various industries. He has authored several papers and is taking technical lectures to students of various institutions. So, it's our privilege to have you here, sir.
Yeah, thank you.
Now, to the participants, if you have any questions regarding the presentation, you may please type them to your WebEx chat box. We will have time for the questions at the end. So now, I call upon Mr. E. Gopalakrishnan to begin the session. Welcome, Gopalakrishnan, sir.
Thank you. Thank you very much for the introduction. Let me start our session today. It's going to be a long session, I hope. And because of this different topic, I brought into the different slides so that when we are opening or closing, you should not have any problem during the webinar. So let my organization on behalf of I'm Dr. Fixit Institute of Structural Protection Rehabilitation is not for profit registered company. It's registered under a Section 25 of Indian Company Act. Our vision is to become a premier knowledge center in the country on repair and waterproofing, other areas of renewal of engineering. Our mission is to provide advisory services on structural repair, restoration, waterproofing, distress assessment of concrete structures with a state-of-art advanced diagnostic laboratory facilities, which is created at Mumbai. So we have been providing these services past 12 years rather, successfully to across the country, several industrial, corporate, individuals, or many institutionals. So that is a brief introduction of my organization. And my organization is having a tie-up and collaborating with the international voice, the Concrete Institute of Australia, and New York Roofing Contractor Association of USA, the Concrete Society of UK, International Concrete Repair Institute of USA, where we collaborate with the latest development techniques. Even we call our experts, exchange the information and understand the latest development across the globe. We are having a collaboration with the organization. There are many national level we are having that I'm mentioning it here. What we do exactly? One is try to provide the holistic solution, because now during the monsoon or later part, the leakage is one of the main issue for individual house owner to corporate or commercial establishment or industries. So we provide a solution, scientific solution. That is the one. Second one, we conduct a petrography on the rock, aggregates, concrete to understand the metrics, mechanism of deterioration, and for example, the fire damage structures. It's a important tool to understand what was the sensitive damage, what temperature the damage happened, and what was the to be done. So understanding that, you understand a little bit investigation of the fire damage structures by using petrography technique. The third one, we conduct a condition assessment of industrial buildings, industrial structures, and houses or the commercial buildings. We call it structural audit. There we provide all the details and start the. And we do testing, some partially destructive testing to understand the properties of structures. We provide the service to the consultant and the predominantly other agencies in the country. So these are our main services. What I explained here, I can show that there is advanced diagnostic laboratory which is located at Mumbai. So all the facilities got accreditation from National Accreditation Board for Testing and Calibration Laboratories. But in short, if I tell you, if I issue the certificate from my laboratory, it is not only valid in the country, it is also valid globally. Even other countries can recognize and accept because it is following international standard, and we have got accreditation for that. And we have been maintaining accreditation. Not only that, even though one step further, we are providing the services of proficiency testing to other testing labs or agencies. When they go for accreditation, this is a mandatory requirement for them to complete. So we are providing the services. So you can say that in yearly 100 to 150 individual such organizations, they are in contact with us. They are coming to us and participate and show their competency after our getting certified by us. For that also we have got an accreditation. And this is one of the photograph which we had been done in the past 2019. Okay, now the introduction part is over. Let me start with our subject today. Yes. So I planned such a way. Let's start with the background and understanding about requirement of the non-destructive evaluation, what are the different steps of assessment, conducting a condition assessment or structural assessment, and several non-destructive testing techniques. We are going to discuss about that much detailed way, and which includes a couple of case studies. I have chosen 2 case studies for you today to give that how we conduct the investigations and how we can conclude it, and then what is the outcome of that. So that will be quite interesting. Meanwhile, I'll be playing some of the audio visuals, and if you are having any issues, let me know so that I can try to set it right here. Am I audible? It's okay now?
Yes, sir. Audible.
Yeah. Let us start a bit background what happened. Since I am staying in Mumbai, I know what's happening in Mumbai very much. I may not be knowing your place. So you have to tell me what is the situation there about the durability of the buildings. In Bombay, it's every year that is a routine. During the monsoon, we get to know this building got collapsed in particular area, other building got collapsed, there is so much life lost and other things. Without any such a incident, there is a never we had a monsoons without any problem like this. Even this year, there are 2 incident happen already in Bombay. One in suburb and one in city. So what happened? Mumbai Municipal Commission, they make all the buildings, they have to go under structural audit and submit the report to BMC. The building which is older than 30 years, they have to do every 3 years frequently structural audit and do the maintenance so that they are keeping it in a proper shape and stability. So I can show the one of the newspaper cutting here where it says that structural audit of 30-year-old buildings is mandatory. This is by law, one has to do that. So 1.5 lakhs building to get BMC notice to get the structural audit. There is another news also you are getting. Dikkat on structural audit of old buildings largely ignored. Yes, many of our people honor this law or they are not following this. Hardly there is a very few percentage people there go meticulously, conduct the audit, submit the report to BMC and take the repair, rehabilitation, whatever required. So that is the regular practice. But many of others, they ignored. This news from Bombay, because being a coastal region. What happened to Delhi? The South Delhi Municipal Corporation asked for structural audit report from the high-rise building, school, housing societies. You will be surprised to know these buildings occupied recently. I can tell you. So this particular building, what I am talking about, it was constructed in 2003. Not even 17 years completed. Still, they issued a notice to do the retrofitting. Already they started strengthening those kind of jacketing and strengthening. You can see it from here itself. So you can understand the condition. Not even 20 years, not even 17 years, already deterioration started. They are afraid. That's why the strengthening measure is started now. This is a situation at Delhi. Okay, now when you're talking about service life, we need to understand all the buildings not achieving the service life. What is service life? Service life is defined as the assumed period for which a structure or part of it to be used for its intended purpose with anticipated maintenance, but without major repair being necessarily done. So without being necessary repair, regular maintenance like painting, some patch repair, that's okay. Major repair like strengthening, jacketing, and strengthening of beam, column, or structural members. So that should happen after the service life only. But it started early in the 17 years. That's what my slide shows. Of South Delhi Municipal Corporation issued the notice. Now, what are the parameters affecting the service life? One is carbonation, the chloride ingress, alkali silica reaction, and the fourth one is freeze and thaw action. But that is not, for us. That is for the other European countries, other countries which is in the cold region. Okay. If you see that, mainly carbonation, chloride ingress, and alkali silica reaction, these are the parameters which affecting the service life. But when you understand the durability, what are the other? Weathering action, chemical attack, or abrasion while maintaining its desired engineering property. So those factors going to affect the durability. Different concrete structures require different degree of durability depending on the exposed environmental and properties desired. For example, uh, concrete exposed to tidal seawater will have a different requirement than the indoor concrete. So where you are having the under the severe circumstances, it affects more severely than the other parts. So durability is based on the exposure condition, we can say. And primary issue, it's starting with the corrosion of rebars, chemical attack, alkali silica reaction, then delayed etching formation. So these are the primary issue affecting the durability of the concrete. Then the multiple transport mechanism, like because of the resistivity of the structures, so the hazardous gases, water, enter into the concrete structural members. Started carbonation, subsequently corrosion, and corrosion means it's losing its strength of the rebar. So you understand that how the corrosion mechanism proceeds further. One is that the actual environmental condition, exposure condition. Second one, during the construction, selection of the raw material and mix design criteria. You all knows about what is the selection, mix design. We have been talking last 3 days continuously on so many things. So I don't see much explanation to be given on this front. Then when we do that, normally we check the specimens because the specimens at the site or at the lab, which we know. Rarely check the specimens. These are all the factors affecting material and process application. The another one is aggressiveness of the environment. So mainly the aggressiveness of the environment, can we do something? We cannot do. We have to live it. We have to design accordingly to stand against. But what we can do, we are having a full material and the application, like selecting the quality of the material, doing the proper design. Second one, the application stage, proper mixing, transportation, compaction, and curing as per the maintained environmental condition and good workmanship. So these are the very important things. Yeah, material and process, it's in our control. We can able to do in a better work. Now, when the durability is what you are talking about, the cover concrete, because many people ignore the cover concrete, they won't give the much attention. Cover concrete is only providing durability to the structures. You have to remember that. Okay, so cover broken means what happened? You will get exposed the core easily with the reinforcement, get affected. So the cover need to be protected. I'm going to show one other schematic stage of corrosion-induced deterioration of concrete structures. There we can explain whatever we discussed. So here we can see that there are 4 stages given. Based on the exposure condition, structure deterioration. What we said, different structures are having different service life, but most of the structures do not attain their service life because of the poor maintenance. So here, in spite of all our precautions, preventions, concrete deteriorates severe and extremely severe exposure condition. So the root cause of deterioration need to be ascertained. So here the stages of 4 stages we are talking about. One is that depersuasion of the steel reinforcement due to expert external environmental conditions. That is the number one, the first phase. At this point, corrosion is possible, but there is no observable or actual physical damage you can see in this first slide, first stage, I can say. The development of corrosion, which is occupying the volume significantly larger than original steel. Generally, we say steel bar occupies the volume 3 to 6 times than the original steel. So what happened? The cracks happen, crack widen and facilitate penetration, moisture and aggressive substance into the concrete. So promoting the faster rate of corrosion, eventually leading to spalling of covered concrete. In the second stage, you can say that there is a stain on the surface, but still you may not be able to see any deterioration. So the initial stage, what happened? There is no appreciable amount of defects or damage. Once reaches the propagation stage, the rate of deterioration increases. This leads to severe damage to the structure, and we need to diagnose and understand why it's happening, how to prevent it, or how to delay all the things. That is required during the propagation stage. So this, which may eventually lead to the collapse in the final, the fourth. Okay, this situation required urgent intervention. So one is initial phase, second propagation phase. Initial phase, the condition established by monitoring. Only we can observe, we cannot do anything more. But in the propagation phase, deterioration established through survey and using non-destructive testing techniques. So I think this one is more clear to understand the 4 stages of the corrosion activity. You all know that what is the corrosion mechanism. The chloride, air, acids, water, other chemical substance or hazardous, if we enter to reinforcement, the corrosion starts. Instead of talking, let me explain through one of the audio visuals. Can anyone tell? They can see that audio visual correctly?
So both are clear.
Okay, very good. Thank you. Discuss about that. What is the chemical reaction? Okay, now this.
Corrosion can be described as a process, a chemical reaction, where refined metals such as steel and iron return to their more stable combined forms as oxides, carbonates, or sulfides.
Okay.
In this chemical reaction, a section of the steel material acts as an anode. This means that the steel loses electrons. On the other hand, another portion of the reinforcing mesh acts as a cathode. In the cathode, oxygen combines with water and the electrons to release hydroxide ions. This shows that the reactions require both water and oxygen to occur. The volume of corrosion products, especially Fe2O3, is significantly higher than the original steel. This will increase the internal pressure and consequently crack the concrete. We know that the availability of these three elements are essential for corrosion to happen. The reaction requires water and oxygen. However, experiments in real case scenarios show that chloride plays a key role in the onset of corrosion. Concrete provides a high alkalinity environment around the reinforcement. In normal conditions, one can expect this will protect the reinforcing bars from corrosion. At the same time, we know that concrete is a permeable material, as moisture and aggressive ions can move through the pore structure of concrete. The interesting question that arises here is the role of chloride ion in this reaction. This has been the topic of research for many corrosion specialists around the world, yet there is no definite answer to it. A very basic explanation is that the ingress of chloride destroys the protective oxide layer on the surface of rebar. This eventually destabilizes the protective film over the reinforcement, which eventually leads to the initiation of corrosion. As I mentioned earlier in this presentation, the porosity of concrete makes it possible for ions to penetrate into concrete and make the concrete itself act as an electrolyte. Corrosion happens in this environment, and the movement of electrons in concrete creates an electrical potential field inside concrete over the surface of rebar. For example, the reactions in the anode, where steel loses electrons, can create a potential difference of negative 780 millivolts compared to a standard copper sulfate electrode. The cathodic reactions would result in a potential difference of positive 160 millivolts. The traditional way of investigating corrosion is visual inspection. However, when damage is detected in visual inspection, it is already too late. Signs of corrosion are often marked with delamination, which is the result of corrosion materials expanding. Visual inspection is often performed with chain dragging tests to identify the delaminated areas. At this stage, there is not much left to do except repair. Corrosion activity is often to corrosion study. The first concept is the half-cell potential. In this method, surface potential measurement is used to predict the probability of corrosion. While the test provides useful information about the chance of corrosion for the area under investigation, the results can easily become misleading if the potential effect of influencing parameters are not appropriately taken into account. Another limitation of the test is that it does not provide any information about the kinetics of corrosion reactions. The second concept is the rate of steel corrosion. The corrosion rate is about the kinetics of reactions and how fast the corrosion is progressing in the concrete. This becomes important in the context of life cycle assessment, as it helps engineers better predict the remaining service life of a given structure. So let's talk a little about these concepts and measurement test methods. The half-cell test can be used to predict the corrosion potential from the surface of concrete. Several associations have standardized the test procedure, including ASTM, UNI, and RILM. In the half-cell potential method, the potential values at the surface of concrete are measured with respect to a reference point. Concrete surface should be prepared before doing the test, that is to remove paint or other non-conductive layers from the surface. The surface should have a minimum amount of moisture. A sound electrical connection should be established between the reference electrode and reinforcement. The value is normally presented in contour plots, showing different half-cell potential values. This helps identify areas with a higher chance of corrosion. For example, ASTM C876 introduces 3 different ranges for the measurement. Half-cell potential values less than negative 350 millivolts, measured in reference to copper sulfate electrode, represent an area where probability of having active corrosion is more than 90%. When measurement is higher than negative 200 millivolts, this probability is less than 10%. Results for half-cell potential values between negative 200 millivolts to negative 350 millivolts is uncertain. Corrosion can be described as a process.
Yeah, fine. So let us continue further. Then, to understand the corrosion and the deterioration mechanism, we conduct a structural assessment. What is the process of structural assessment? We will be discussing a bit. First, we must have the knowledge on the structural distress analysis. So we go through the, investigating the structures, distress structures, understanding the symptoms for cracking, deflection, vibration, spalling, whether it's a fire damage, etc. That is the one part. Second, we use the non-destructive techniques to understand what is the property of this structure which is hidden inside. Based on the diagnosis, we propose the repair rehabilitation, whether it's a structural member, non-structural member, how to do the repair or replacement required. This is a process of conducting the structural assessment. For conducting a structural assessment, there will be a different scope. One is strength assessment. If you want to assess the concrete strength, we can do few tests. Durability assessment, we understanding the what is the deterioration, whether it's a corrosion has happened, what extent it happened, to understand the durability. Integrity means to understand behavior of the whole structures. So the scope of the assessment need to be defined initially before we start the things. This non-destructive testing evaluation required for routine inspection check, like a condition assessment of the structures with a given frequency. Maybe a legal purpose, the seller want to know what is the condition, or buyer want to check the condition of the building. Then maybe structure in distress, they want to do further. What is the planning? Whether we need to redo or we need to repair. That is the one. The third one, whether when what you are doing a repair rehabilitation, what extent we need to do, what is the cost, when we can do. For that, we understand the condition. And finally, retrofitting to the current requirement of new standard. That means currently you are occupied and using for some purpose, you want to convert, increase the live load or dead load or whatever the matter, or increase the 2 floors above. So you try to understand the condition for retrofitting point of view. This is all the requirement for evaluation of non-destructive. So the structural testing is required. Mainly we do is determining the strength or to check what is the quality and condition of the particular structures, or is there any integrity issue is there. If there is any localized issue, any specific area we are having some issue, we can check that to assess the potential durability of the structure as a whole, to identify causes and extent of deterioration happening currently. For this are the reasons for conducting structural testing. Now, when the main objective of this lecture today to share the present and the recent applications of NDT and evaluations and condition assessment of the building with a special focus on real-world applications. So we can talk about many things, but what is happening today? So this is a typical stage-wise process of condition assessment. We do the preliminary investigation, desktop study, reviewing the document records, the repair history, etc., and rapid visual inspection to identify the deterioration, the reason for deterioration. Then we do the diagnosis, planning for what is required to be done further. That is planning for the detailed investigation. This is the initial assessment. When you go to the detail, we see sampling, because we cannot do each and every member. So we select the member, how many percent and how many members we are going to do that. We conduct the initial in-situ testing. Then we send a sample to the laboratory to understand the strength or properties, etc., chemical properties, etc. Then at the site, we do the distress mapping and conduct the desktop study. Based on the desktop study, we understand what is the problem with the structures. Then this all the things if we collect together, we evaluate the results, interpretation and accessibility, what is the whole sum. Summarize the findings based on the field investigation as well as laboratory testings, and we try to bring out in the final report. There we recommend for the proposal of methodology of the report based on the deterioration. So the phase 2 covers all the testing, interpretation, and making a final report for recommendation. This is a complete assessment process of structural assessment. In this stage, there are few steps involved. One is that we conduct the step one visual assessment. Second one, NET scheme, what test to be done, where to be done, what is the number, because this also involved a lot of cost. If you want to specify more number, definitely the cost multiplies. Number three, we have to depend upon the group of entity tests, not the single one, because many cases we can observe nowadays, say they do one or two tests and conclude that what is the condition of the structure. It's not that. We need to conduct the group of entity testing to supplement each other. Then some of the district tests also need to be conducted. Then laboratory test, as I mentioned in the previous one, the interpretation of all the NDT test and laboratory test, prepare the recommendation, and finally giving the cost estimation. How many members we are going to do, and what kind of method we are going to adopt, based on even the material selection, and based on that we will have the estimation of the cost. So this is the one we do initial stage to understand the overall structures. When you're talking about visual inspection, we may take a sounding method using the hammer or dragging the chain. So this is all the technique followed when the larger area is there. But when you further, we select a non-destructive testing. What parameter we want to know, we can choose the test. For example, if you want to understand the uniformity of the concrete, general test is the core testing. Somebody categorized semi-destructive or partially destructive or destructive, whatever you call it. The core is one of the important aspect. Then cut and pull out. This is the one less damage is creating the less damage to the structures. It's very well introduced nowadays. I am going to give the detailed about cut and pull out test detail. Then you're all familiar with the rebound hammer and petrography analysis, understanding the matrix of the deterioration, the matrix of the cement binder, what is the binding strength, etc. When you see the rock, we can understand the mineralogy of the rock, what is used to prepare the concrete. All the information we can get it through petrography. Mainly, we can get the information Faraday image structure size and area. Then ultrasonic pulse velocity. This is all the some of the tests if you want to know the concrete uniformity. Then delamination and voids, cracks. These are all creating a problem for durability of the structures. Or hammer sounding test, chain crack test, which I have shown to you. Then impact echo test to understand the uniformity. Any delamination is there, voids is present there below. Infrared thermography to understand not only the delamination, also understand the source of water leakages, and ultrasonic pulse velocity, and remote viewing through the sensors and all. So that sometimes may not be applicable. That is also, we have to insert the strength at critical locations. I keep monitoring through the GPS. So that is a remote sensing. This all the parameters we can select. So when you understand the compressed strength, NDT method for using what are the compressed strength property, simple and quick method, we use the rebound hammer. And understand the integrity of the, the homogeneity, we use the ultrasonic pulse velocity. And cut and pull out test, we can get the quick strength. Instead of doing a core and waiting for many days to get the strength, cut and pull out strength will help you to get the quick strength. Maybe 20 minutes you can spend to do the test at the field. Then and there you can get the strength of that particular concrete or member. Overall, when we complete all the NDT, interpreting all the things, we categorize what is the condition of the building. There are 4 categorization: C1, C2, A and B and 3. Based on that, they can take action further what to do. The C1 category, it's an unsafe category. Immediately need to be vacated, immediately demolished. C2A, it's need not to be vacated completely. Only the particular portion where it's dangerous portion, that should be cordoned off or vacated for doing the repair. C2B, the building isn't dangerous, but need not to be vacated. Only we need to do the major repair or strengthening. That is the C2B. And C3, the building is, there is some minor issues, some surface cracks or something. Otherwise, everything is all right. Only we need to conduct touch repair or something. So that is the C3. We categorize what is the category, and subsequently, based on the categories, we say that if it is based on the severity, we take appropriate action to conduct the repair. Okay, so now let us talk about the non-destructive testing techniques. Recently, the non-destructive testing is more frequently used for evaluation of the condition assessment of the buildings. Yeah. The purpose is to test integrity of a material or structure and condition or health assessment of the structures. Okay, to understand the material property, strength property, we conduct non-destructive testing. We are going to talk about very few and in a detailed manner. As we are discussing the destructive testing, one is the core example. And pull-out test, there also we need to drill and damage, partially get the pull-out test. This are coming under destructive. What is a non-destructive method like Smith hammer or the ultrasonic pulse velocity? Those techniques and several other techniques used as a non-destructive testing techniques. So let us see one by one. One is the Smith hammer. It's a very simple and very useful. We can get the in place uniformity of the concrete to in place. Very easy to use, most in the field, and this can be study uniformity of the concrete. This also based on the surface condition, presence of rebar and presence of subsurface voids can affect the test result. So the standard, that IS 13311 part 2, and the principle you understand that measuring the rebound on spring-driven Morse hammer after impact with the rod in contact with the concrete surface, as you can see here. So you can push to release the rod and prepare the test, and we can say what is the rebound number in the lock position. That's what we are going to do it. This is a very simple hammer. But how it's working, that operation? See, that what is that pushing the house and releasing the hammer? The force is returned back, so that you can able to see what is the number going to displayed or shown at on the hammer. So that is the principle it's working. The test, you can able to understand what is the rebound number noted here, the 41. Okay, now let us new hammer comes. Now they are talking about Q value. Generally, when we use the we talk about, okay, R value is generally we use for manual or digital instruments. But Q value, more electronic one, which is having a more correlation coefficient, which is 0.97 compared to 0.84 of the R value. So you will get a more accurate results in the latest hammer Q value. The Q value is not affected by the orientation of the instrument. We don't need to do the correction. Tend to have the less dispersion than the traditional rebound hammer. Okay, so anyway, the Q value is not comparable with R value. The standard says that. The strength, how you get the strength? We need to prepare a comparison chart. Now, provided that the instrument should not be used, we have to take the estimation from the compressive strength based on the similar material, whatever we have done. Based on that, we can have closest estimation of the compressive strength. We cannot give exactly the same. That we have to understand. That's why we say that we have to take the other group of tests to establish the correlation. We cannot decide any, the stability parameter only with this particular test. What are the factors affecting the strength and the elastic modulus of concrete near to the surface, like aggregate type dependence or thickness of the carbonation zone, which is going to affect more than 50% of the strength is going to get affected because of the carbonation. And the surface structure, whether it's a smooth or rough, based on that, also we are going to get the different result. Surface moisture conditions and rigidity of the test object. There are so many reasons results get affected. We have to be careful. That's why we have to take several readings, and we take the index of 6 reading to report as a rebound number. So as we saw that, as we shown here, we can able to see different directions. What is the strength correction we have to make? Okay, angle correction we can say. So when you are eating the stronger portion, definitely you will get a rebound number. When you are eating to the weaker portion, we will get based on the surface. Okay, as per ASTM, they take 10 readings and they report.
Hello, sir. Hello, sir.
Bring a quick review of the rebound hammer.
Hello.
Hello, sir.
Sir. Hello.
Gopalakrishnan, sir. Say you are not audible, sir.
Hello. Hello.
Inspectors should pay attention to the following considerations prior to
Hello.
Yeah. Right.
ease of use. It is an inexpensive for non-destructive testing evaluation of concrete to estimate the development. In order to test against concrete perpendicular to the surface, as the hammer body is pushed towards the concrete.
Yeah, sorry for the disturbance. I will run once again. Run the audio visual. Are complaining because of.
Okay.
Yeah.
We'll be covering a quick of the rebound hammer testing method. Its introduction in 1948, the rebound hammer has been extremely popular and ease of use. It is an inexpensive, quick method for non-destructive testing evaluation of rebound are to assess the place forming concrete
Thanks.
and to estimate the concrete erosion is developed. In order to test, the plunger is pushed against the concrete. Is
Hello, sir.
a higher
Con-
inspector should a test should also always be smooth before testing. Concrete surface must be removed. And finally, it's important not to test on frozen concrete. And concrete should only be tested after it has thawed, since frozen concrete tends to have high rebound numbers. Although the rebound hammer provides a quick, inexpensive means of checking the uniformity of concrete, the results can also be affected by the following parameters: smoothness of the test surface, size, shape, and rigidity of the specimens, age of test specimens, surface and internal moisture conditions of the concrete, type of coarse aggregate, type of cement, carbonation of the concrete surface, and type of mold. With recent advancement in sensor technology and development of wireless communication, a new generation of rebound hammers are commercially available. Recording and tracking job-specific details, including hammer angle and on-site verification of test results, was time-consuming and prone to errors. The new generation of hammers help engineers get around these issues. For example, new generation hammers apply real-time checks on the quality of datasets and do not need to be adjusted for the configuration of the hammer.
Yes. So typically this hammer need to be get calibrated. Can you hear my voice?
Yes, sir. Yes, sir.
Can you hear in response?
You're audible, sir.
Continue now.
Yes, sir.
Okay, fine. So typically the new I'll use this anvil for calibrate. Every 200 impacts, you need to calibrate. So how we can use the correlation curve? The 10th percentile curve is used for correlating the likely strength of the concrete. Okay. So this will help to minimize the number of the cores. Core taking is a very tedious and destructive. And we can take the collected sample or representative of the investigative structure wherever we can able to do comparative study. Okay, so we have seen that what are the limitations with that. Now little bit quick we can go through that. We talk about next one is a ultrasonic testing of concrete. This is an efficient method for quality control of concrete material, detecting the damage the structural. For this also, there is a latest standard IS 516 Part 5 Section 1 for UPV testing is published now. So this is a old one, IS 13311 Part 1 waiting absolute now. Still, it's valid, of course. Okay. Now, the UPV methods have been traditionally been used for quality control of material, such as metals or welded connections and RC everywhere. Okay. The latest transducers can able uniform what is the path length traveled by time give the velocity. I am not taking much time on this. So now you can see transmitter and receiver to receive the signal and displayed on the screen. Okay, this is the latest Pandit lab, which can give more accurate results. The concept is a different type of method. One is transducer and receiver direct to each other opposite direction called direct, which is more reliable, which gives the result. Semi-direct, sometimes we may not able to get the direct, so that we can use the semi-direct. Sometimes only surface probing only possible, but it is the least reliable based on the accuracy. Only the advanced users can interpret the result. Okay, these are the methods what we use it. Then if you understand quickly how we describe the defect, presence of the defect in the concrete, the first one, the question is very solid. And that well here. Concrete. We can see that. Yeah. Can you say something? Okay. So
Voice was
okay. I see. I see. Let me check it. My signals are correct. Okay. Yeah, there's some. Yeah. Just a minute so that I will. I will. Like now it's okay or still the same?
Now it is okay, sir.
It's okay, no? So you want to me repeat or you want me repeat or continue?
Just to repeat from the previous slide, sir.
Yeah, this from this one onwards.
From this one
So,
onwards, sir.
okay, fine. So in this slide, you can clearly see that what are the defects, how we are detecting it. The trend, the first when you are having the uniformed concrete, and if it's honeycomb, the second one, it's taking more time, travel time at the another end for receiver. So if it is a crack, it's taking a diversion. If the crack is larger, definitely it is not passing through. So that you can understand the velocity is zero, there is something definitely more problem. So you can understand the defect and interpret it. So it is ultrasonic pulse velocity detection of the voids, cracks, other internal imperfections or defects. Generally, we can able to do. Otherwise, also we can able to understand the property of material like porosity, density, strength, or elastic modulus. In this slide, my main purpose is to show how the imperfections can be detected through the ultrasonic pulse velocity equipment, or how can able to detect the crack depth estimation. Okay, this is what my main objective today. It's used as a quality assessment, void detection, crack depth measurement. I was mentioning it, and understanding the other property of density, modulus, strength, etc. Okay, I'm not going to read that straight away. I can able to see that what is the application. So delamination we can able to detect, and through the pulse velocity determination, and quality assessment we use at ultrasonic pulse velocity, establishing homogeneity and uniformity of concrete, and measurement of surface crack depth, prediction of the compressive strength of concrete we can able to do. Now, UPVs, used for reliable understanding the homogeneity and strength we have been talking. This also going to affect on the certain parameters, concrete properties, okay, transfer is really placed or not, and the presence of river, and the
Sir, again there is some disturbance in.
or completely can be through the raising of alkali aggregate, alkali silica, corrosion. Earlier, the crack happens due to many reasons. Usually, we try to measure the crack width scale, but about the depth is very important. As an engineer or the structural engineer want to know what is the depth of the crack, so that they can take the crack depth is to evaluate the structural integrity and verify durability performance. Okay, so one is that you take a core and absorb what is the depth from the core and other thing. Second one, use the non-destructive testing to understand the crack depth. That's what we are going to see here. Yeah. Now, in this picture, they clearly, as per IS 516 Part 5 Section 1, is mentioned that how the crack depth measurement can be made that. So there is the equal distance from the crack. We have to place two transducers and receivers, as well as from that another 2 point we have to take to understand this crack depth or estimating the crack depth. Better I can tell you, instead of explaining to that, I can show the audio visual to you so that you can. Please tell me if you are getting a clear or not.
For determining thickness of concrete, but also can be used for crack depth. Today we're just going to have a quick look at determining depth of a crack in concrete. So I'll just turn the instrument on, hit the button
It's
up
fine,
here.
sir.
I'm going to hit measurement mode. Now there's a number of selections here because we've selected crack there, so we're already in that mode. Here's the dimension B, which is 10 centimetres, 100 millimetres. That's how far we are either side of the crack, and twice that. So this is 100 millimetres and 200 millimetres, or 10 centimetres and 20 centimetres. There's our 10, 10, 10, 10, etc. So I'm just going to put some coupling on the ground in line with this. There's a bit of coupling, bit of coupling, bit of coupling. Just measurement here. Now I'm going to put the two transducers, one transducer there, one transducer here. They're not actually on the tape, they're just next to the tape. So first I'm going to hit play. I can see here this is auto mode, where it automatically jumps and automatically finds it, etc. Now I'm going to just move that because I can see quite clearly that the signal is actually received. It's actually there. So I'm going to select that. Now, next thing I'm going to do now, I'm going to jump to the second set of measurements. So I'll move my two transducers there, one here and one there. Now, we now hit this play button again. Now, this isn't jumping. Oh, sorry, hang on. I just hit something by accident there. I've need to come back out. I hit zoom in, hit that plus button. So I'm going to set it back to auto mode. Now, it's jumped to that spot, but I can see quite clearly that the nice clean sine wave starts a little bit earlier than that. So I'm going to move it back, and I can actually see the sine wave is really just starting there, and I can see that pretty clearly. So now I hit finish on that, and it's got a crack depth of 44 millimetres. So it's that simple, that quick to find your depth of cracks in concrete. Nice little instrument. Thank you very much.
Yeah.
For determining.
So when you are determining the crack may not be the straight line. So the crack profile, you can see that, like for example, it will maybe zigzag. So we have to measure and take the average so that you can able to get the exact depth of the particular crack. Okay, so we have taken several readings and then we have taken an average, because some of the cracks are shallow, some of them are deep. So we can able to take the average. So based on that, we can able to report like the crack 1 is a 0.083, crack 2 0.044, crack 3 is a 0.060. We can able to report the crack so that we can take the appropriate measure to repair the cracks. And the second one is the cover or performeter, which is working on the eddy current principle. It detects the cover as well as the diameter of the rebar. So both we can able to get it more accurately. Within a 1% accuracy, we can able to get it. So this is one of the picture shows that how they are measuring at the field. So its advantages give the accurate cover and estimation of diameter of the bar. But what are the limitations? It can detect only the top layer. The conjecture area, you may not get the accurate result. You can able to see in this picture. So bar size, I said, within the plus or minus 1, you can do that. And search shade need to be located directly over the bar, parallel to the bar. Not close to the neighboring parallel bars or not over the transverse bars. So this will mislead. So like you can say that this one is correct and these are all not correct. We are not measuring correctly. Second one is the carbonation. Carbonation process, carbonation chemistry, you all know. I'm not going to repeat it. One is the pH. It should be above 12. And the carbonation, how it's affecting the dropping the pH below the 9 or 8.5, so that the positive layer, its breakdown and the corrosion progress in presence of oxygen and moisture. So that is the carbonation. When you take the core, you can spray the planthallin 0.2% concentrate planthallin, and we can able to see where the color changes portion, so that we can measure the depth of carbonation from the surface. So this is one example, is a minor corrosion. It is a very minor in this one. If you see the next one, yes, there is a corrosion depth, carbonation depth is much more higher than the previous one. So we will move to the next. Next, we are going to talk about the corrosion inspection and monitoring. See, when we are commonly observe the existing of reinforcement concrete structures, when performing the structural condition assessment, so we need to find out what is the current state of the structures and what is the rate of corrosion happening and what is the remaining capacity and service life of the structures, because corrosion is a very, very important parameters. For measuring that corrosion, we use Galva Pulse GP 5000, which is combination of offshore potential and the resistivity, and also giving the corrosion rate at a real time. The three properties you can get from this instrument. Mainly, we try to understand the corrosion rate. The important things here, we are using silver chloride electrode. Generally, when you see the offshore potential readings, they are copper. This one is much more accurate. Copper sulfate, silver, right? The scope of that measuring the corrosion rate, offshore potential, and the resistivity. That what I said. This called the Gaulow pulse measurement technique is fast polarization technique for determining the actual corrosion rate at the time of test. So you can say real time of readings. So the instrument looks like that with the probing and handheld computer, which it's calculate the resistivity, the rate of corrosion, as well as offshell potential readings. It measures current and the resistivity by calculating galvanostic pulse measurement. Okay, and it will tell you how much corrosion you have now in the structures and what is the potential of corrosion in the future. Based on that, you can able to determine what is the action to be taken on this. So using the Gaulow pulse, why use the Gaulow pulse? Because it will give the corrosion rate. Other instrument not giving. Offshell potential reading. Predict the lifetime. Based on this, we can predict the lifetime of the structures. That's we call it residual life of the structures. Whether after how many years it's going to have the complete corrosion, so that the breathing get deteriorated completely. Okay, what is the proactively you can extend the service of the structure's lifespan. Okay, then how we are going to use that, decreasing the rate of corrosion and providing the control measures. When you are estimating the corrosion rate, you see, when you're having lesser 0.5, so lesser than 5.8 micro milli per year, it's going to have the corrosion. Based on that, you can have what is the corrosion level? Is a passive level. So there is no deterioration taking place, visual deterioration not taking place. Then 0.5 to 5 microampere per centimeter square corrosion happen. What is the rate of 5.8 to 58 micromilli per year. So that the low level of corrosion, it is greater than 10 years. 5 to 15, 58 to 174 micromilli per year corrosion rate going to happen. Then it's considered moderate. It is 3 to 10 years. Then what 15
ഞാൻ പറഞ്ഞത് എനിക്ക് 10 ഞാൻ എടുത്തു എനിക്ക് 10 ഉണ്ടായുള്ളൂ പൈസയിലാണ്
the corrosion level is considered high if it is greater than 174 micromilli per year. It is considered as a higher. It is a less than 2 years the deterioration will happen. So this is the conversion we can able to read the corrosion rate table. Okay, that's the interpretation of measure it. So the three parameters, offshell pattern provide the information of likelihood of the corrosion is occurring currently, and resistivity give the offshell provide the qualitative indication. Polarizations provide the measurement of corrosion current. Okay, based on the property, we can able to get the residual life of the structures based on the polarization resistance RP. Okay, so when you're doing the things, even the 10 seconds, you can apply the galvanostic pulse into the structures. We can able to get it, and it is also give the electrode. We need to probing with the electrode with a different we can say grid format. We can able to do that. From record the voltage history, we can evaluate the polarization resistance RP. The God ring which I shown that is used to do the grid mapping. Okay, the string theory relationship curve we can able to see here. So 1 microampere per centimeter square equal to 0.012 mm per year. This is what we can get it from the String-Curry equation relationship. We can able to use contour mode to see that what is the representative corrosion which is severe and which is acceptable with the different colors here. Okay. The yellow orange is very much higher on the severe part. So similarly, the option potential reading. Then resistance in ohms. We can use it understanding the service life estimation of the structures, evaluating measures such as application of corrosion inhibitors, membranes to protect the structure, or electrochemical removal of chlorides by using, now there is a latest technique what we are using, and also as condition survey of corrosion activity continuously. This can be fixed at the permanently. We can able to understand what is happening time to time basis. Okay, we can say that if it is you are repaired, you are done that, and what is the measuring corrosion activity in the repaired areas. So we can able to understand this all the application of this developers measurements as per CM7 ASTM C876. How the evaluation of corrosion is given that the severe 404 millivolt to 254 is 90% probability is high risk of corrosion, and between minus 254 to minus 104 it is a 50% probability medium, and higher than 104 towards the positive it is a low risk of corrosion, only 10% probability. We can able to interpret the results accordingly. Understanding the kilo ohms, higher corrosion probability, medium corrosion probability is intended to, it's a more than 20 or smaller corrosion probability, understanding the resistivity point of view. Okay. So the corrosion rate measured using polarization resistance represent the rate of time of the test only. These are limitations in this particular test. Because corrosion rate is going to happen continuously, it may change. Okay. Anyone suggest that? Do you want to have any break for 5 minutes?
So we can take a 5-minute break. So
Yeah, I hope that if we can have a 5 minutes break and come back. Please ensure me so that I can continue here.
okay, so now it's
Thank you.
3:17. Okay, we'll have to come back at 3:22.
3, yeah, fine.
Go.
Yes. Yeah, let's continue. Can you hear me now?
Okay, sir.
Okay. Okay. Welcome
Okay.
to everyone. No. Am I audible? No.
Yes, sir. You're audible.
Okay. Yeah. Thank you. Now, continuation with the non-destructive testing techniques, we are going to discuss about infrared thermography, which is the miracle of non-destructive testing, I can say. Other equipment, on the surface probing, you have to do. This one, you don't need to do absolutely nothing. Just non-contacted temperature measurement. Okay, it's detect the defects in the structures, and it can help understand the moisture direction, moisture movement in the buildings, and the energy loss in the building. So we can able to identify through this. Now, if you are having the leakages, we can able to identify through the thermal scan, showing that what is the water leakage from the ceiling. In the monsoon, we get the peak demand for this service. The pandemic situation, the customers are demanding this service. Our whole team out in the field even today, so they are doing the services with a lot of infrastructure project or under construction project or completed project. The people living the houses and commercial buildings, there is a lot of demand in this. We are keep doing these things. What you see in generally in the normal, we can see in the thermal what is the leakage spot or where the water intensity, moisture moving, etc., movement, etc. Like you people knowing that those who are traveling international or national airport now, they're having the TV screen. They keep on monitoring through the thermal imaging technique only. Because of this COVID-19, the people are coming with high fever. No need to check each one of them showing the temperature gun on their forehead. The camera is fixed. You are keep walking through that, the channel. You can get identified who is having what temperature, so that it will be easy for the official to screen the those who are coming with high temperature. Okay. And the understanding the roof problems, roof leakages. If you see the normal, you won't be able to understand what was the nothing. Same thing, if you use the thermal image, you can able to understand there is some issue. There is a detected in the thermal scanning. So in the particular point, you can able to see that whether the waterproofing membrane is damaged or there is a damage in the slab itself, or what is another problem. So we can able to identify, pinpoint the exact location. Beating around the bush, you can able to pinpoint. It is a rapid screening. You can save a lot of time. You can rectify the problem in a rapid way. So I'm going to discuss about one of the case study here, which is I don't know whether many people may be familiar with Bangalore. Is a close to airport. This is a 13th floor building. On the 13th floor we have got a swimming pool covering both towers. I did myself 2 years back, so that I thought it will be more appropriate to share with you my experience. When they constructed commission, the people have started buying the home, and they started living there. All of a sudden, very early stage, there was a leakage from this pool to down. The water was dripping continuously. Even if you understand this much height, even the single drop falls, it will make a big noise. With that, the builder, they are not able to sell the more plots. There is a complaint from the residents, those who are already started living. Everybody afraid the swimming pool may collapse. What will happen when the swimming pool collapse in the overhead 13th floor height of the 13th floor? So that is so much important. They want to do the understand how to correct it. They contacted several people, but they not succeed. I went from Bombay to Bangalore, stayed 2 days continuously for this particular work. I stayed there at the site, and understanding what is the problem happened, what is the reason this leakage is causing, and everything. Finally, they satisfactorily they have completed job. After completion, the builder has circulated the report of this particular swimming pool to all their sites. Everybody trying to contact me. Even they face small issue, they're trying to call me. Then I told them, if there is any important things, I can travel down. There will be a worth for my travel from Bombay to Bangalore. It is not that I'm not staying there. I can visit all the site at once. So when there is a problem, still that particular client is in contact with me and try to sort out the problem. I'm going to explain what was the reason. So this is a swimming pool in the close-up look. So it's a very luxury apartment. It's a very posh locality. So the size of the swimming pool, there is a two swimming pool. One in front is a kids swimming pool with a 0.6 meter depth and 1.2 meter depth for the adult one other side. So you can see the closer view. They put some barricade to guide the water. Yeah, close look I show. Yes, it's already open. The water is dripping from here continuously from the deck. If you go to the 13th floor, there is a one trap entry. It's been very difficult for me to enter. I went to several times to below the swimming pool to assess what's happening. They have been doing a lot of repair activity. They are not able to sit even. The height is so less than 0.4 or something. But people are there to grouting and doing something in the blind way because they don't know what is happening exactly. So you can see there is a small passage we can able to enter. There is a dark completely. You have to carry the torch when you go there. Yeah. Now the deck is there. That's why the leakage is not able to see on the floor anywhere. Only on the joint between the wall and the slab joint. There you can see the water dripping continuously. We don't know where it's coming. Only the edges, both edges, you can see the water dripping. They are blindly grouting there to stop that leakage without knowing the source. So totally the mess. They did a lot of chemical injection. Nothing happened. when you see that how it was constructed, this is a quite interesting history. They have taken one of the top waterproofing system to see that which very high elongation property, tensile property, and durability property. Even in 25 years, there is no need of doing anything, any repair maintenance. That kind of product they have chosen. Still, the water is started leaking. So I am showing that step by step how the surface preparation done, and there is a primer done, and there is a geotextile, and there is a mesh over it, and again the gunneting work done to strengthen that waterproofing system. Okay, now you can see gunneting and the ponding. It was kept more than 2 weeks. There was no single drop of leakage during the construction. Everybody was quite happy. Okay, so this is the one when I visited, before I told to empty the swimming pool, I started investigation. I spent 2 days completely. I could not get through anything. On the third day, with the help of infrared thermal imaging, I got the source. So you can see that yeah. Okay. So there is a water. It's returning back whatever entered when the swimming pool was filled. When you do that, returning back because of the pressure. Finally, after understanding the drawing and the pipelines and everything, the damages I found, where is the problem is there. This was identified as the source of the leakage. Once we have done that repair on the particular area, the leakages got stopped completely. Okay. When you ask anything, you won't think anything. Yeah. The source of the leakage detected, and we asked that the contractor to do the the grouting certain areas, and also taking the proper measures to applying the polyurethane sealant, some grout, and tile joints to be fixed properly. Everything they have done it. Okay. Then the stage wise, they filled up the swimming pool and observed whether any leakage is coming further or not. Okay, this was the completed job. It was quite satisfactory. Thank you for that, and we'll move on with another interesting one. Nowadays, if you want to know the strength, definitely everybody go for taking the core and getting the strength done by the laboratory. So this process takes 4 to 5 days. In this one, taking the proper coring, trimming it to parallel, and curing it 48 hours before testing with a capping. Then applying the load systematically. That is also very important. Otherwise, majority of the cores get failed. Doing the core is such a sensitive matter. Measure of the time, it's get problem. So in place of the core, what is the best option? It is a pull-out test. It's normally used for early diagnosis of the strength problems. However, this can be used to evaluate the strength of concrete in existing structures. Okay. So the core, when you do, it's a destructive test. Not only damage of the concrete integrity, it might affect the reinforcing board and the reinforced structures. So what is required? Drilling the core, it's a high cost. Number and penetration method, ultrasonic, this required a correlation. We cannot give as it is. So pull-out test, more reliable estimate, we can able to get it directly and understand what is the strength of particular structure or member. So as per ASTM C900, we use pull-out test, which is cut and pull out. Second one is cast in place. We have to cast the ring and do that. Very difficult to do it in many cases. We are not going to do it as a part of the structure, assurance. But what we are going to, when the problem happens, then only we are going to estimate the strength. That's why the post installed may not be possible. The cast in place may not be possible. That's why we use cut and pull out. Just I'm going to explain few slides how the cut and pull out works. Okay, when you insert the ring, we have to use applying the equipment to pull out it. Then we will get the conical fragmentation. We can have the correlation of the pull-out load versus compressive strength, so that we can directly convert into the compressive strength. Okay. See, based on the pull-out test, we can able to understand the plasticity, so that before form work or removal of things, we can able to understand what is the strength achievement. Compression strut theory, aggregate interlock theory. This basically pull-out strength related to fundamentally to the concrete strength. You can able to see compression set theory. It is not affected by whatever the type of cementitious here, whether it is OPC, PPC, slag, whatever it is saying. It is not going to affect the water cement ratio. It's not about the age, air entertainment, type of admixture. Up to 40 mm, no problem. Lightweight concrete, however, see, there is a different correlation between the normal and lightweight we need to establish. Otherwise, it is not going to affect the density of the aggregate. Okay, it does not require the pre-planning. We can perform any location, even the structure members. You try to see the reinforcement location in between. We can even the congested reinforced location. We can find a place to do it. Okay, and it's an immediate result. You can get it immediate 20-25 minutes. You get the result. You don't need to wait 4 to 5 days like a core. I keep on repeating the same. So how it's happened? They prepare drilling the hole, 18 mm dia hole. See, like the surface preparation, the diamond cutter is there for preparing a smooth surface. Like this is one prepared one. And there is a groove under this. Yeah, you can see that. Yes. They create a groove. This is a special drill, create a groove. Then we are placing the ring, coiled type of ring. You can able to see. That one getting it expanded when you are pulling out. So we are tightening the nut, then applying the force whether at 2 points. So why is this not It's the actual aggregator sign. It's not a professional audio. Actual structure. Mobile structure. You can see that there is one technique. Right? Let me explain to you another. Yeah, we can see the damage. This is the only cone portion got damaged. This is a ring actually. So the correlation curve, this one for cylinder, the one for cube. We can able to convert the pull-out load to the compressed strength easily, right? You can able to see what is the actual pull-out and the cube strength. Then studies here. I can show you what is the result we conduct. One is the capo result and the cube result. So the is one used for doing the pull-out test. Second one used for the normal compression. In both, you can see the how much closer reading we have got. This is the first one. The second one, you can also see that when you are comparing to the core, what it did, the same place where we have taken the sample, no, adjacent to that, I have taken the core, and I am comparing those results with capo test, which I got it there, so that we can see there are more or less close, except one is a little bit difference, because always this variation we can bound to happen in the concrete, but major closer values. The same thing we did in the cube also. One cube we do the capo, and the same batch of the cube we will do the pull out. So sorry, normal. Our results are within the tolerance. And the concrete is within 15% of tolerance is acceptable within the group of the cubes. Even this one less than 6% tolerance we are getting it. So it's a more accurate. Clearly. Pull-out test offers the possibility of estimating in-place concrete with acceptable liability. The test stated by the reach the compression step that explain the okay. Out pre this is, let me try. It's okay now. Yeah. You want to me start with the other things because I'm having some signal issue here. It's okay now? Okay. If there's anything, please let me know. Otherwise, I can switch over to hotspot. Okay, great. Yeah. Now I have to explain this case study before concluding this session. You want to me connect? Just give me a second because it's breaking continuously. This is a time happening every day. It's not only today. And the evening time, I don't know what's happening. So let me connect it.
Oh.
All the things.
Oh.
No, give me 2 seconds. Huh? It's okay now? Yeah. Okay, I am coming. Yeah. Now we're connected with the hotspot so that there is no interruption. You can able to see my screen now?
Yes, sir, able to see.
Very good. Thank you. So let's talk about this case study before we concluding the session. This is quite interesting. This is a water reservoir. We call it a clarifier at thermal plants. Generally, you can able to see. It is a NTPC. And what is the problem? There is a water is leaking from the tank, and also the structure deterioration happening continuously. So the maintenance team is got worried too much. It is happening long time. We try to do several methods, but nothing is working out. They approached us for understanding complete study and giving the solution permanently. Okay. So the details, it was at Ramagundam in Karimnagar. It's 2,600 megawatt. It's the largest in South Asia, 250 kilometers from Nagpur. Okay. It has got a 4 clarifier, but they want to do 2 is deteriorated very much larger. So that's why, sorry, what happened? Yeah. So our scope is to conducting the inspection clearly, using the thermal imaging, conducting other non-destructive testing, group of non-destructive testing, and also giving the report with the recommendation and rate analysis. So that's our scope. So this is a typical the clarifier. So how the chlorine, lime, and has been used, and mixing with the water, and the water quality, what is expected, turbidity less than 20 NTU, and the chloride is 0.2 ppm, and pH 5.5 to 8. This was the desired output quality. Okay. So I'm going to fit fast now. The capacity of the clarifier is 7,260 cubic meter, and the height is 3.5 meter at the edge, 4.5 meter at the center, and the external wall 3 meter from the ground level. Okay, internal is 4.1 meter. These are details, and there was 24 fans. There is a thickness of the wall 500, and M20 grade was used there, and all the joints were leaking. They're broken. I'm going to show the pictures. Okay, main problem, the horizontal cracks in the periphery, about 1.1 meter height, and vertical cracks, most of the location at a 2 meter level, what you can see from the left-hand side. The leaching out, because of the water continuously seeping through that, the 500 wall, there is a leaching out everywhere. You can see the patches here. Yeah, in the close view of the leaching out patches. So when we use the thermal image, we can able to see what are the area, the water intensity, or the source of the leakage very accurately. That is the first point. Even the some places we observed, not only the moisture, also water is dripping continuously. Okay, So both can be identified and assured that this is a point is a problem leakage spot. And we emptied the clarifier and we see that inspected clearly after draining water and cleaning done, visual inspection was carried out along with the infrared thermal imaging to identify the spot. This is what the cleaning in the very first after emptying the tanks. Then you can see the floor because of the damage, cracks, and everywhere the floor got damaged and vertical cracks everywhere where through the water is seeping from inside. We have taken the picture. So we can identify what are the weak spots creating the source of the leakage, high porosity, and where the minor crack also, allowing the water to seeping through. Identified. Only thermal imaging can help us to identify those areas. Okay. And even the results, what we can see, we have used all the NDT, the UPV result found, somewhat satisfactory. Only the errors of 5% and 6% was less than the unsatisfactory level. And rebound OMR is given a good result, about 30 rebound numbers. It's, strength is okay as long as. But what are the other parameters? Even the cover is adequate, except 2 numbers, 3 numbers, each one not good. But otherwise, the majority cases cover also is a 30 mm. It is provided. The chloride is higher than the permissible limit. That's the leaching you can see, and the pH lowering less than 10 some places, and carbonation 5 to 10 mm from the surface. One clarifier you can see 7 to 12 mm. So that's why the carbonation also not affected. It's a very earlier stage. The cover is adequate. They given a proper protection. But where the problem is, the offshore is showing that high risk, medium to, they are getting the reading minus 135 to minus 723 millivolt. That's the one. The resistivity also showing inadequate. This, corrosion is happening. So these two things they given high corrosion probability because of the resistivity. Then we can see the UPV value less is okay, satisfactory in the clarifier majority, 78%, 83% found satisfactory. Okay. And then offshore potential, if you see that how much here, 70, 86% is, severe, only 14% lower. That means it is a high corrosion. And the clarifier one, how much? 25, 50% probability of corrosion severity and 50% less probability. So overall, the corrosion activity is happening because of the continuous leakages happening and the structure. So we have to take the effective action immediately. See, high to severe, I said, minus 254 to minus 4.4 millivolt by silver chloride when we measure. So this is as per ASTM C876 is specified. Okay, even the resistivity gives very much negative. It is also showing that the probability is higher. The clarifier 2 is 56%. Here 36% plus, how much? Minus 37 we are getting. This also higher. So more than how much? 63%. 3% is probability of corrosion happening. The walls, the final cracks 1.1 meter height, there is a horizontal cracks. Major leakage happening through the construction joint and vertical cracks from ground level to 2 meter height. These are the problems we identified. When concluding that, we can say that visual inspection and non-destructive testing technique overall condition terms be good. The average of results seems to be on the better side only. The problem for the leakage, it's happening through the floor. We can see a lot of cracks and the damage in the construction joints. These are the places. Because of that, the corrosion is also effectively very high. So we recommended to fix the leakages first and repair the cracks from inside the tank and internal surfaces and give the protection. Whatever you repair, you apply the repair material, we need to protect it because it's going to water retain structure continuously. There's going to be a water. This was the recommendation we have given that. So what are the each point, expansion joint, cold joint, or structural cracks? We told them to repair with a cementitious, with the crystalline based product, so that it's have the crystalline growth and break the porosity and make it proper impervious surface, and as well as the growth in the concrete or the repair product. So we are given that stage wise what is the coating to be given internal side, and what is the motor to be used for repair, and what is the coating to avoid the dampness to enter the moisture or water into the concrete wall or floor. So we are given the complete solution, and finally we recommending with epoxy based anti-corrosive treatment wherever the corrosion happen, and we provided the epoxy coating, coal tar epoxy coating, to protect the repaired surface. So this is a BOQ. Item-wise, we give rate analysis so that customer can take it further. So this is a stage-wise photograph. You can see how the repair being carried out, all the 24 joints, and the epoxy coating has been done as a protection measure. Before completion of the job, this is a completed job. Now still this running, it has been done in 2017. Now last 3 years, almost 3 years now, there is no complaint or anything received so far. Okay. So this is an interesting case study I want to share with you. And finally, before time completes, I'll take a few minutes. When you want to know the mechanical properties, you select what kind of non-destructive testing required. Okay. See, if you want to know the compression, you take core or rebound hammer or blow test anything. If you want to know homogeneity, quality, you can use the ultrasonic pulse velocity, tensile strength, pull-out test. This kind of things you can select to understand the, like a bond strength means pull-up testing. When after repairing the surface, you want to know what is the bonding with the substract, repaired motor or something, we can able to do the pull-up testing. Like that, you can select what you want. The chemical properties, electrochemical activity, yes, of course, the corrosion activity need to be done by understanding the corrosion rate, axial potential, resistivity, carbonation, the phenolphthalein solution, petrography analysis, and X-ray diffraction, infrared, spectrography, etc. We can do that. Alkali aggregate reaction, petrography analysis, very suitable method. Chloride, see, we use the analytical method to understand the chloride on sulfate. So how to interpret the result? If it is the high UPV value, high impact hammers, it's not a corrosion prone. Medium UPV, low rebound, yes, there is a delamination you may have. So you have to use, corrosion prone zone. It's a low quality of surface and the corrosion prone. Low UPV, high impact numbers, there is no corrosion. However, chemical tests need to be performed regarding carbonation, chloride ingress, and pH, etc. Low UPV, low impact number is a totally corrosion prone, required to chemical and electrochemical tests like a corrosion related and chemical test to ascertain. So cover meter also required. Cover meter takes good quality concrete, relatively corrosion, not corrosion prone. The cover thickness and bad quality concrete, yes, definitely the porosity will increase, corrosion prone zone. Less cover, even though if you are having good quality, again it will be a corrosion. We can able to correlate the result based on these techniques. Now coming to the concluding session, already time is up, so I want to be in time. The availability of wide range of NDT devices has made it easier to monitor quality or distress or durability of concrete structures. Okay, the NDT devices has been proved to be reliable and invaluable rather than the conventional testing. Depending upon the requirement, any 2 or more tests, NDT tests, or to contractor to get the required information regarding the quality and strength of the concrete. Doing a rebound number, if I'm saying that your structure is, not having the strength, it is not having a stability, that's not correct. I'm trying to tell that. Okay, interpretation of stress is required. Competent person to arrive at accountable estimation of concrete regarding and strength. When you are using the instrument, definitely bound to get the result. That is not the end of the story. You need to have the person who is experienced and competent to interpret and guide you properly. Okay, that's very, very important. Thank you very much for your time. I think we have kept our promises completed in time. My contact details are there. If anybody want to, communicate, yes, please note down. Or if anybody want to ask questions, I request the organizer to facilitate. They can ask the question. I can answer you right away. Yes. Yeah. Yeah. Is there any questions? I can take answer for that. Yeah. Thank you. Thank you very much.
Hello, sir.
Yes.
So we have a question. How will you select a location to perform the CAPO test on a member?
See, you can select if you are having any structural member. First of all, we need to identify where is the rebar. To avoid, we need to drill a hole approximately 18 mm. Yeah. Yeah. Yes.
Sir, please continue, sir.
Yeah, what I'm saying that if you identify the rebar locator to avoid drilling on reinforcement, that's all required. Then we can do wherever is possible. Only you need to have the space for working. That's all. We can conduct anywhere. Okay.
Okay, sir.
Yeah.
We don't have any question in the chat box. I request the participant to unmute and we can ask directly to the
It will be much easier. Yes.
participants. Please ask your queries to Gopalakrishnan sir.
Yeah, you can unmute and ask your questions if you have got any. Otherwise, I will be happy. I explained to you clearly so that there is no question from you.
Does anybody want to ask question? So we are hello.
Yeah.
We are not. Father
We are
James there, sir. Hello, sir.
Yes, sir. I'm James. I'm asking you
Yes, Mr. James.
for a polytechnic level students, which type of MD non-destructive test they should to set up a lab for these polytechnic level students for practical purpose. Which are the tests you should suggest?
Yeah, I can suggest you some of the basic tests, starting with, like a rebound hammer and ultrasonic pulse velocity, understanding the corrosion, like off-shell potential, and adding to that, you can take the extracting the core and testing into the compressive stress. This is good enough for the polytechnic student. Okay, so basic level, they can able to practice and they can do themselves.
Okay. Thank you, sir. Thank you, sir.
Yeah.
Okay. Thank you, James Davis, sir. Anybody? So meanwhile, I have a question.
Yes, please.
So have you heard about the Palarivata Bridge in Kerala?
Sorry. No, I'm not having any clue.
Okay. So it was recently constructed, but it is certified as unserviceable
Okay,
recently.
they should be detailed study might have done it based on only they might have given based on the material or design or the the performance of the functioning, you can say. So based on that only they might have given. I don't have any clue right now, so I may not comment on this. I feel
Sir,
there should be some reason. Basically, they might have declared means there should be a which is under the Kerala highway authorities or central government, National Highway Authority.
National Highway Authority, sir.
There must be a
And,
reason. If I know the reason, I can advise.
Okay. Sir, if you can conduct
Yeah.
any non-destructive test to
Somebody
assess
may be
the
trying
quality.
to speak.
Hello, sir.
Yeah, please
Are you
ask
audible, sir?
question.
Sir, if any possible test to ascertain
Oh,
the
voice is breaking. I'm unable to hear you. Otherwise, you can how is your
hello, sir. Are you audible, sir? Am I audible now, sir?
I'm not getting full of fully. I'm very sorry. I'm not able to hear you completely.
Okay, sir. Okay. Hello, sir. Can you hear me?
Yeah, now it's okay. Yeah, please go ahead.
Okay, sir. Sir, can you suggest any method to ascertain the quality of the concrete used for that bridge, or whether the reason
See
is
what in my presentation, I am repeatedly saying that when you are conducting a non-destructive test, see, you need to assess and ascertain what is required, what test you are going to select. I given that selection of that. If you want to know the strength, we can select a group of tests. If you want to the uniformity, you select. If you want to the chemical, even the drilled sample can be taken to send it to the chemical lab for understanding the the presence of chloride, presence of sulfate, or understanding the pH of the particular concrete. So we depends upon that. As a consultant, we can able to choose what is required for that, because being understanding the background, definitely I could have selected, but unfortunately I don't have much idea about it. So if you want to share with me, I can help you to identify and suggest you what is the best. Okay, you can share with me the little bit background of that later on, one to one. I will help you to identify what need to be done.
okay? Thank you, sir.
Okay. Fine. There is a possibility for doing everything. It's not that nowadays so much development has been made into the non-destructive testing evaluations. So we are using day by day new methods, new technology, so that it's highly possible
Okay,
to
sir.
do anything unless there is a basic design error or something we cannot get corrected. If it is the other problems, definitely we can set right.
Okay, sir. I
Yeah.
request any other participant want to ask question. Otherwise, we need to.
Yeah. Otherwise, I want to have Mr. Hemant is there.
Hello, Hemant, sir. Can you hear?
Yeah. Any comment from him? Just I want to hear from him because he is the one organizing this from my side. So I want to hear from him. Good evening. Yes, Mr. Hemant. Good evening.
Sir, actually, it's an excellent program, sir. Okay.
Thank you.
And what even I have already explained to Mr. Babu that actually we have required a simple thing, and we have you have given an excellent detailing and pull out and all. I have just seen now itself.
Yeah, right.
Only. Okay.
Now only the acceptance coming to the industry. We had been using this the last 3 years, but recently we are getting the more demand for this. People understood after several conferences and meetings. They understood the importance.
Yeah, sir, what I feel actually, because core test actually most of the time people are not ready to do, because most of the time people thinking that it's a destructive test. Okay, what you
Absolutely.
have told.
Yeah.
Okay,
Yeah.
so this pull-out field seems to be very good. Seems to be, and unfortunately, what will happening, sir? Most of the time, these people are try to whenever some strength issue will be happening in concrete, people are trying to do this pulse velocity test actually. Okay,
Yeah.
so there is a misconcept also there in the market. That is also the problem what we are facing.
Yeah.
Yeah.
I can tell you slightly my experience.
Yeah.
I was heading the quality control, quality assurance department of Delhi Metro. When Mr. Sridharan was, head of that metro, I was working there for the underground. Okay.
Okay, sir.
There,
Okay.
we brought the specification from Bangkok. We have not followed any specification because we bought the same specification done by some the financier, the Japanese bank. They are a Japanese contractor. They suggested that we can go for the Bangkok specification. Same thing we follow. In that part of the specification, when I am purchasing the equipment for the laboratory or quality control laboratory, I was wondering there is a lot of big list of NDT instruments. I was wondering why the instrument. We are we need to construct the metro tunnel. We are not going to use the NDT. Then they asked me to, you please study the specification. When I studied that, when we complete the work, as a performance ensuring, we need to conduct the non-destructive testing as a routine method. It's not that they're satisfying with the cube testing, cube properties. We used to conduct the non-destructive testing every portion of the metro in front of the the consultant who is supervising the job. So both will be doing that as a part of quality control. Myself and consultant will be ensuring this particular member is constructed, my particular retaining wall is done, whether it is having a required quality. We ensure that we use all the NDT tests during the metro. It is not that after failure we trying to use UPV or core taking or rebound hammer. No, nothing like today. I'm sorry to say, a lot of RMC being produced. When the failure comes, immediately there will be a task force goes with NDT instrument. NDT instrument not going to change the value. Okay, so they are trying to find out the structure is the problem or not. That's what they will try to do, because this is still in India, we are not developed at that level. Part of quality control should be used for the structures to assurance the structure is done properly. There is no voids, there is no honeycomb, there is no less strength at the structure. That's why the performance-based durability we are talking about in the ICI nowadays. Okay.
Yes.
So that is the situation I am explaining, because other countries, they are following NDT as a part of the routine test. Fine. But still we are, when the problem happens, we try to, do that.
Okay.
Thank you, Hemant sir, for being part of our session.
Thank you very much. Yeah.
Okay, sir, we can wind up the question and answer session. I hand over the session to Basil sir.
Yeah, please.
First of all, I invite Renju AJ, lecturer of Central Polytechnic College, Vattiurkavu, to come forward to give the feedback.
Okay, am I audible?
Yes, ma'am.
Good evening, all of you. First of all, I would like to thank Civil Engineering Department of Government Polytechnic College, Muttom, for organizing this FDP sponsored by SITTER on the topic concrete technology, which is both academically and industrially relevant. Regarding this, the session was really informative. The contents of the session, like the necessity of doing non-destructive testing and the different steps of its assessment and different non-destructive testing techniques were all well clearly explained. Also, the case studies discussed at the end of this made the explanations complete. So I thank you, sir. Thank you very much for sharing your experiences with us and for such an excellent lecture. Thank you, sir.
Thank you, Renju.
Thank you very
Ma'am.
much.
Next, I would like to invite Shani T.S., Assistant Professor of Jai Bharat College of Engineering and Polytechnic. Ma'am, please.
Good afternoon. Myself, Shani T.S. Hello, am I audible? Hello.
Yes, ma'am, please continue.
Okay, good afternoon. I'm myself, Shani T.S., lecturer at Jai Bharat College of Engineering and Technology. First of all, let me thank for giving me such an opportunity in this session. And the session was very effective in understanding about the non-destructive methods and the advantages for assessing structural conditions. Actually, it was a very different topic, and some information were very new for especially me. And in this occasion, I thank you Gopalakrishnan sir, for giving us such an informative and effective class. Thank you all. Thank you.
Yeah, thank you very much. Thank you very much for your comment.
Thank you, Shani, ma'am. Now, I would like to invite Miss Jyoti George, lecturer GPCM, to deliver the vote of thanks.
Thank you. Good afternoon to all. Now I take this opportunity to thank Mr. E. Gopalakrishnan sir, Head of Lab and Consultancy Service and Pidilite Industries Limited, for gracing this faculty development program with your important class and sharing with us your industrial experience. We understand that you have taken time out of your very important schedules to contribute to this session. Thank you for your informative session on non-destructive methods with a lot of case studies. I extend my heartfelt thanks to the Renjumis and Shanimis for their valuable feedback. I also extend special gratitude to Hemant sir and all participants who have attended the session. Thank you.
Thank you, Jyotis.
Thank you very much, ma'am. Thank you.
Now it is time to wind up today's session. Both of the sessions were very much effective and useful to every one of us. Once again, thank you presenters for sharing your knowledge with us. Participants, also please note that our next day morning session will begin tomorrow sharp at 9:50 a.m. Everyone please join on time. Thank you, sir. Thank you for being here.